Okay guys, the laser is ready to fire.
Now, it may look like we're amidst a military operation at the moment, but the people behind me, they're not soldiers. They're actually environmental scientists. They're on a mission to discover how much water is escaping into the atmosphere.
Australia is the driest continent on Earth, so our water resources are very precious to us. But at the moment, we're using our water far too quickly. Now, 90% of the rainfall that comes onto the continent is lost as evapotranspiration. That's made up of transpiration, which is the loss of water through plants to the atmosphere, and evaporation from the soil and lakes.
So is that what you're using this high-tech laser equipment for, to get some sort of understanding of that?
That's right. With this equipment, we can measure the evapotranspiration and get an understanding of how our water is escaping into the atmosphere.
The laser is the first of its kind in Australia. Setting up the laser properly is a science in itself.
Can you just bring it closer?
So how does the machine actually work?
Well, here we have the laser, and this shoots out a very strong, sharp beam of light. And as it passes across the landscape, it changes according to the temperature of the air that it's passing through. Now, down the other end, we have the sensor, and it can detect the changes in the air temperature as it moves through the landscape.
Is that kind of like when you see a heat haze on the road?
Yeah, that's right. So the heat haze that you see is as the temperature above the road heats up, it's much warmer than the temperature of the air above that. So we get pockets of air which are different temperatures, and this causes refraction of the light waves, and this is bending of the light, so we see the image shimmering. Now, the same thing is happening here, but on a much smaller scale. We can't detect it with our eyes, but as the laser beam moves through pockets of different temperatures of air, the light is refracted and the sensor can pick up those changes in the beam.
And what other information do you have to collect to make sure that these readings are accurate?
Well, we collect information about the incoming energy coming from the sun. We use a radiometer to do that. And then we also work out how much energy is going into the earth. We use soil heat flux plates, and this lets us know how much energy is being absorbed.
Once all this information is gathered, they can then accurately calculate the amount of water being released from a site. But why is this information important?
When we talk about available water, we often focus on how much water is in our dams or how much rain has fallen. But we really need to think too about the evapotranspiration, because it's such a vital part of the water cycle. By quantifying the evapotranspiration, measuring exactly how much water is going into the atmosphere, we can determine how much water will be left for use in industry, for use in our homes, and for the environment.